Good morning, everybody. Let's just give it, maybe a minute or so for more people to join. I hope everybody's having a great Friday so far. Okay, I think we can go ahead and get started um, because of time. So again, welcome everyone to Elos Midtech, and thank you for joining our webinar and taking the time for that. My name again is Mo Elbana. I'm the regional sales and development manager for North America. I'm also your technical advisor. And excuse me, I'd like to remind everybody with just a couple of quick reminders, just like every webinar, that if you are a CDT and you are seeking the credit for this webinar, and you have not placed your CDT number in the form, please ensure that you send me your CDT after, your CDT number afterward, along with your first and last name. Also, due to time, I will not be able to answer questions during the webinar, but we will definitely have a few minutes at the end to answer everybody's question. And a couple of things about Elos and our legacy before we jump into the hybrid base. Just to remind everyone that we certainly have a couple of significant milestones in the industry. The first one came in 1975 when Elos was the company that produced the first titanium components for Professor Brennemark that he tested in the process of the osseointegration in rabbits. We were the company that actually manufactured those components for him. And our second and significant milestone came in 2010 with introducing the very first scam body together with 3Shape. So Elos or Elos Accurate has been evolving in the dental industry and the dental space ever since. Also, our clear focus on quality and precision, and that comes from us have been the manufacturing and developing company for implant companies since 1992. So the majority of implant companies kind of come to us when they need help with manufacturing some of the components, and that is makes the Elos Accurate line the go-to brand from the leading implant companies. We also have been known for predictable solutions, high quality and precision aligned digital and physical components through the digital smart flow that we have to ensure predictable solutions. So we are passionate, trustworthy, and result-oriented. We have compatibility with nearly all of the major implant companies out there. So that said, let's start our webinar. And so before I start on the specs and options of hybrid bases, let me just clarify one simple term here. At Elos, we call our tie bases hybrid bases, but the most common name for them is tie bases. And maybe you look at a company like Straumann, they call them vario bases. At the end of the day, everybody's talking about the exact same thing. So please don't let that throw you off. Now, obviously, our prosthetics, including the hybrid bases or tie bases, are part of our digital solution or smart workflow. We always start with a library for that, and then you need the scan body, and then based on what your design calls for, whether it's a tie base or a pre-milled blank, and then we have the printed model analog, which we talked about last webinar, for the process of verification, or if you want to have a printed model. Now, these are the main prosthetics that we have, but not obviously the only thing we have. If we look at the evolution of tie bases from Elos standpoint, obviously here, as we see in this diagram, in 2015 we started with a tie base that didn't have much geometry or retention helixes to it, which is right here. And then a year later, in 2016, we introduced our generation 1 with what we thought the market needed at the time. We added retention helixes to improve the bonding on this line right here. And then a couple of years later, in 2018, we introduced generation 2, which is basically the same as generation 1, but gold anodized. And then the anodization from that moment on became our standard, basically. So every tie base of whatever shape, form, or fashion we produce today is going to be gold anodized. And then in 2021, we introduced generation 3 to improve on some of the things we got as a feedback from the market during the years between 2018 and 2021. Obviously, you know, as we produce stuff and we put it out in customers' hand, based on the feedback that we get and what improvements would be necessary as things evolve, we try to also stay on top of our game and evolve with everything to still accommodate the market as we see fit. So generation 3 has several enhancements from generation 2, and then also now what we are going to have next year is generation 4, or hybrid base G, basically. That is coming in 2026, the early part of 2026, and that is truly going to be a game changer. We will have a specific webinar when the right time comes on hybrid base G, but that is a significant improvement from what we have right now in generation 3. And if we look at this evolution timeline of hybrid bases versus custom abutments, for example. So initially we start with just a stock abutment, and then we have the first trial of hybrid bases, which did not really have any geometry or retention helixes like I described earlier. And then we launched generation 1, and then generation 3 is what you see here in this picture, you know, with a lot more enhancement. You know, it is taller with, you know, gold anodization, really nice retention helixes and whatnot, and a feature to have the angulation and whatnot for angulated screw channels. And then when you look at hybrid base G that is coming, it's actually a lot closer to a custom abutment than anything we have had in the market prior. Again, we will have a proper specific webinar on hybrid base G when the right time comes, but stay tuned for that. It is a game changer, and it is literally as close to a custom abutment as you can get, but in a hybrid base format. Now let's kind of dig deeper into what we currently have. So what we currently have right now is generation 3 and generation 2. The two that you see on the right side are the engaging, the two on the left side are the non-engaging. The very short one here on the very far right is generation 2 engaging. Then the one next to it with the taller chimney is generation 3 engaging. And then the two on the left here, the one on the very far left is generation 3 non-engaging. And then the tapered one next to it is generation 2 non-engaging. Now, obviously, like I said earlier, As things evolve, we tend to listen to the market, see what the need are, what improvements we need to make to accommodate the way things evolve from many different perspectives. So on generation 2, the engaging hybrid base was pretty short, so it did not really accommodate cases that had a lot of occlusal clearance. You had a lot of crown here, a lot of zirconia, for example, but not so much support underneath it. So we made sure to enhance that in generation 3. It does have definitely a taller chimney, but what also generation 3 does not have is options on the gingival height. So if we look at this picture, it's very deep subgingivally, where in reality this really needs to be somewhere here, but still keep the height for the support. Now, we're going to focus on the H line, and that is generation 3 on hybrid bases. So the H line offers our locking area, which is on the top of the hybrid base. So the end user does not have to sacrifice material thickness. Many of our competitors have the locking mechanism down by the margin area. But with ours, we maintain the locking mechanism on the very top to allow for better aesthetics. Placing the locking area on the bottom, like most competitors, like I said, will result in a very bulky restoration by the margin area. So if we look at the flat areas here that you see highlighted in blue, those areas make the triangular or tripod feature, and that's what makes the anti-rotation mechanism. Now also that guides the crown and forces it in a one-way insertion direction, and then the U-shape here allows for the angulation feature, which can be up to 28 degrees. Now if we look at generation 3, the chimney height is the H line is 5.5 millimeter. Generation 2, it's 3 millimeter. On the non-engaging, on Gen 3 or the H line non-engaging, it's actually 4.5 millimeter, and then on Gen 2, it's 3 millimeter without the antenna. If you add the antenna, it's 3.9, but without the antenna right here, and that's what we call this little guy right here. We call it, we refer to it somewhat like an antenna, but it is 3 millimeter without and 3.9 width. Now, the advantages of the H line on Gen 3, obviously the most important one, or the very first one on the list, is the base lock, and that is our built-in locking area or anti-rotation feature to improve the mechanical retention and the positioning or position stability, which is right here. Now then you have the U-shape for the angulation, and then we have our 40-degree chamfer, and that has the mating surface phasing out to 0 right at the margin line to encapsulate the cement. So this chamfer area here is at 40 degrees. Right at the margin line, it is 0 cement gap. And then it kind of opens up, and then the cement gap starts where the retention helixes are. And then obviously we have the retention helixes, and then both lines follow the implant diameter, and also super precise connection. And finally the lot number. Aside from our screws, all our other prosthetics are laser engraved with the lot number, even though it is still not a requirement in the US, but we have been engraving lot numbers on our prosthetics from over 10 years ago. Now on the non-engaging H line, It was really truly designed specifically to enhance the aesthetics and bonding, and that's where you see the flat area on the like the shoulder kind of like area right here for the seating. And then we also made it somewhat straight without much tapering at all. We're going to talk about that in more details in the next couple of slides. So if we look at the guide grip, which is right here on Gen 3 or the H line on the non-engaging, and that those little areas right here refers to the two small antenna like to help with the locking, the restoration in place for tri-end, for example, or maybe for during bonding. And that also enhances the mechanical retention in the bonding stage. So these antennas like are intended to help hold or clamp the hybrid base into the restoration in the correct orientation and position during cementations and or during the laboratory or clinical workflow to improve the efficiency and accuracy of the seating. The same benefits that we have on the engaging also come with the non-engaging, the guide grip technology, the U-shape, the retention helixes. We follow the implant diameter, accurate connection, and the engraving of the lot number, of course. Now, on the right here, we see the implant level abutments or hybrid bases. This one right here is 5.5 millimeter on the engaging, and it is 5 millimeter on the non-engaging. Now, versus the abutment level hybrid bases, both of them for engaging or non-engaging sit at 4.5 millimeter. So both of these at 4.5 millimeter, and those two here on the implant level, the engaging is 5.5. and the non-engaging is 5. Now, this is a question I get more often than none. It's regarding our screws. We have two types of screws. One is the prosthetic screw. The second one is the hexaloblar screw. I know it's a mouthful, but if you practice it enough like I did, you can pronounce it. So both of them, the threaded area are exactly identical. The threaded and the seating area are exactly identical to the original. The prosthetic screw right here and right here, those are a replica 1-for-1 from the original. So they can be swapped with the original screw. And we make them exactly like the original screw from whatever that manufacturer is. If they're coated, we coat them. If they're not coated from the original manufacturer, we don't coat them. They can be swapped, like I said. You could use our screw versus the original screw or vice versa. And we don't even make a driver for those prosthetic screws. The end user will use the original screwdriver from that particular implant company. However, the prosthetic screws are intended for cases or can be used for cases that don't have any angulation, just for straight up and down channels. So if there are no angulation, you could use our prosthetic screw, you could use the original screw, either one alike, no problem. For angulated screw channels, if you are using our component and you have an angulation on the chimney, then that's where the hexaloblar screw comes in play. The hexaloblar screw seating area, again, like I said, and the threaded part are exactly the same. It's just the screw head is different. So therefore, with the hexaloblar screw, you will need to purchase our screwdriver for that. So our driver, the only driver we have for screws is for the hexaloblar screw. And the hexaloblar screw is intended for either angulated screw channels or can also be used for straight up and down no problem. However, the prosthetic screw is only for the straight up and down channels. Debonding issues. One of the most common laboratory challenges is the debonding situation. But if we look closely at some information here, some of the bonding do's and don'ts. In reality, one of the most common things that we as technicians have learned many years ago, and we kind of maintained as a bad habit that we cannot shake down. If you look at a lot of the technicians, the very first thing they want to do before they bond their tie bases to a restoration is they're going to do two things. One is to go steam it or sandblast it first, then steam it. And both of these things nowadays, especially with the Elos line, are a huge no-no. And the reason why, anytime you actually sandblast a surface, this is a non-sandblasted surface. And these here are the retention helixes. If you sandblast them, you're basically blending and significantly reducing the retention capability on that. And sandblasting, through a study that I'll show you here in a sec, has proven to reduce the bonding by 50%. That's very significant. So nowadays, and I want to say this generally speaking, but especially for the Elos line, if you are trying to use our tie bases, please do not sandblast anything. Not only that you're going to lose the anodization, but you are going to reduce your bonding by 50%. And also that will cause microfractures in the future. This study here, that was not done by us, by the way. This study was done by BioHorizon at the University of Birmingham in Alabama. Or the University of Alabama at Birmingham, my apologies. So even though back in the days, because of tie bases at the time, many years ago, did not have any retention mechanism of any kind, and the material, the way we process things was completely different. We were taught to sandblast everything before we bond, and we continue to do so even though things have evolved. So today, in what we have in the market, especially from the Elos line, sandblasting and steaming are not a good thing. So please do not do either one. Just make sure you clean it with alcohol, and because steaming also will introduce oils and other debris that is going to interfere with the bonding strength. And just bond it the way it is. Don't sandblast, don't steam. Now, our bonding guides are available on our website. They are in a PDF format that you can easily download and go over the step-by-step procedure. But you also want to follow the procedure and the manufacturer recommendation of the bonding material that you are using. Again, our lifetime guarantee. We have spoken about this almost on every webinar, and I always like to refresh everybody's memory. It is just like the original, and it is 1-for-1. Whatever the original manufacturer warranty covers, we will match it 1-for-1. And that is including the implant. For the Elos parts, if something fails because of something that we did not do properly on our end, we will either reimburse you or replace those parts for you. And if the implant ends up failing because of our components, then we will cover also that implant along. So please remember again, our warranty covers 1-for-1 the original warranty of that implant manufacturer. And another reminder on the regulatory and compliance. Our clearance and or approvals are in all main markets worldwide. We do not operate anywhere in the world before we make sure we have all the necessary clearances in a particular region or in that region. And thank you very much for your attention and attendance, and we will get to the questions at this time. All right, so hopefully that was informative enough for you guys. And we do have one question here stating that do we have a recommendation on a particular bonding agent or bonding material? So to answer that, all our testing was done with the Katana V5 bonding material. But that's not necessarily the only bonding material that you can use. It's more important that you follow the manufacturer recommendation on that bonding material more than anything else, because every company will have their own process to achieve the most bonding strength out of that material. And again, just to remind everybody, if you did not place your CDT number in the form, please make sure you send it to me so I can ensure that I am submitting everybody's names and numbers for credit. And that is all the questions that we have for today. I appreciate everybody's time. And happy holidays for everybody. Until next webinar, you guys have a good one. Take care, and we'll see you next time.